So hello guys, hello, hi everyone. So how are you guys? I hope you're fine, right? So welcome back guys once again to Rio Academy classes. So today we are going to start up with a new session guys. So as you might have seen, determinants is the topic that I'm going to take up now for PGCET students. MBA and MCA entrance examination, PGCET examination is tended to be in the month of October guys. So October ಅಲ್ಲಿ examination most probably ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಇರಬಹುದು ರೀ. So you need to prepare in your work from now itself. Okay, you should keep on working guys repeatedly. Practice is what gets you through this examination. So revision, that is the key too. So repeat ಆಗಿ ಅವೇ questions ಬಂದಿರ್ತವೆ. Same questions will be asked to you on a same basis, same concept. You have to practice it, you have to revise it. Then we'll be moving forward with the dream that you have, that you should get into a good college so that you can have a good career guys, good future. If you need that, you need a good placement too. So there are some of our top institutes in our Karnataka, especially in Bangalore, like RV, BMS, Areva. So these are the top institutes. In order to get there, you should really have a very well and top rank guys, so that we are going to help you out in order to achieve and make your ideas put into effect. Okay, so those guys who are watching me on YouTube guys, do like the video, share it with your friends, subscribe to our channel so that notifications will be let to you know let to be known to you on a prescribed time. Is my voice clear guys? Okay, if you have any kind of technical error, so please let me know in the comment section. Okay, so Dhruva 2.0, this is the batch. As you can see guys, this is the batch that the second batch that we have already launched, and it is at its end now. These are the educators, so top and highly experienced educators who will be conducting classes for PGCET students on our app guys. Daily classes will be uploaded on your app to recorded format and also live. So if you have any kind of queries or doubts, you might let us know guys. Okay, so fine guys, so today we are going to start up with the determinants topic. As you all know, a very easy topic, matrices and determinants. One question will be asked for you in PGCET examination, mathematics part, of course for MCA students. MBA students don't have the mathematics part guys, they have the quantitative part, which will be covered up by the graders. Okay, he will be covering quantitative and logical reasoning part. So coming back to our topic guys, determinants, that is the topic we are going to consider today. So as you are well aware guys, matrices, we have covered it up in the previous class, so there is not too much of complication in case of matrices, just the part where you need to know the different types of matrices. There is only one question guys which I think will be asked to you in PGCET examination with respect to matrices, and that is what about symmetric and skew symmetric matrices. Okay, inverse of a symmetric matrix, inverse of a skew symmetric matrix, those are the kind of questions which they have been usually asked in PGCET examination. So let us just initially look at what skew matrix is. Okay, skew matrix and skew symmetric matrix, we'll look at that, and then we can move on to the determinant part. Okay, so here is a set of properties guys. I want you to remember these properties because these are important and might be asked in examination as a 1 mark question. Okay, see now, as you already know, matrices is nothing but arrangement of elements in rows and columns. Okay, if we arrange elements in form of rows and in form of columns, then such a representation is known as a matrix. Now what do you mean by skew symmetric and symmetric matrix? These are the two different form of matrices which are important guys. I hope you are well aware with these, but let me just tell you again. See, symmetric matrix, as the name suggests, symmetric means overlapping guys. Symmetric really means overlapping. Let me just consider an example here, and that will be clear to you guys. Principal diagonal elements, those elements are what we usually consider in case of symmetric matrix in order to identify whether the matrix is symmetric or not. Okay, so this is an example here that I am considering. See, this is a matrix B and elements are as you can see 2, 4 and 9. These elements form principal diagonal, hence they are known as principal diagonal elements. 6, 4 and 6, this 2 forms a diagonal, but this diagonal is a secondary diagonal, and these elements are known as secondary diagonal elements. Now if you observe the matrix here with respect to the elements that have been mentioned here in the diagonal, okay, the remaining elements are overlapping, correct? This 3 and this 3. If you fold the matrix according to the diagonal, the elements are overlapping. 3 and 3, they are both overlapping, means the elements are same. And here too, this position 6 and 6, these are same elements which are nothing but overlapping. Speaking in terms of physical, we call it as overlapping. Physical ಆಗಿ ನಾವು ಮಾತಾಡಿದ್ರೆ overlapping ಅಂತ ಹೇಳ್ತೀವಿ. If you speak it in terms of mathematics, we can say the respective elements across the principal diagonal elements are one and the same. Okay, so here it is 6, here too it is 6, and here it is 5, here too it is 5. Okay, so these kind of matrices where all the elements apart from the principal diagonal elements are same and equal, or they are overlapping. So such matrices are known as symmetric matrix. Okay, symmetric matrix. Or you can also say a symmetric matrix is a matrix where even the transpose remains same. ಅಂದರೆ ಯಾವುದೇ ಒಂದು ಮೇಟ್ರಿಕ್ಸ್, ಆ ಮೇಟ್ರಿಕ್ಸಿನ ನೀವು ಟ್ರಾನ್ಸ್ಪೋಸ್ ಅನ್ನು ಕಂಡು ಹಿಡಿದರೆ, ಇಫ್ ಯು ರೈಟ್ ಅಪ್ ದಿ transpose of that matrix, transpose and the original matrix, they both will be same. ಏನ ಒರಿಜಿನಲ್ ಮೆಟ್ರಿಕ್ಸ್ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಮೆಟ್ರಿಕ್ಸು ಎರಡು ಸೇಮ್ ಆಗಿನೇ ಬರ್ತವೆ. ಅಂಥ ಒಂದು ಮೆಟ್ರಿಕ್ಸನ್ನು ನಾವು ಸಿಮೆಟ್ರಿಕ್ ಮೆಟ್ರಿಕ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ದಿಸ್ ಮೆಟ್ರಿಕ್ಸ್ ಹಿಯರ್ ಬಿ. ಸೊ ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ದಿಸ್ ಮೆಟ್ರಿಕ್ಸ್ 2, 3, 6, 3, 4, 5, 6, 5 and 9. If I write the transpose, guys, transpose is represented as bt or b dash. That is what we have seen in our previous class. Fine. So rows are converted into columns. So 2, 3 and 6. If we write in the transpose, this row becomes column 2, 3 and 6. 3, 4 and 5 becomes 3, 4 and 5 in form of a column. 6, 5 and 9 becomes column 6, 5, 9. So interchanging of rows and columns. So rows are converted to columns, columns are converted to rows. So this conversion is finally represented in form of a matrix again, which is represented as bt or b dash. And if you see here, both b and bt, they are one and the same, correct? This is the transpose and this is the original matrix. But if you see, original matrix and the transpose of a matrix are one and the same. So symmetric matrix is a kind of a matrix where the original matrix and the transpose of the matrix are one and the same. Okay, so on the basis of this, in your PGCET examination, one question is asked most commonly. What is that? Inverse of a symmetric matrix. What will be the inverse of symmetric matrix? So this is a most common question that is asked in PGCET examination. See, inverse of a symmetric matrix will always be symmetric itself, guys. Okay, it will also be symmetric. Why? Because as we have seen here, in case of a symmetric matrix, the original and the transpose are one and the same. So here, even if you consider the inverse, how do you determine the inverse of a matrix? Inverse of a matrix is generally represented as A inverse. Okay, A is a matrix and A inverse is the inverse of that matrix. We usually calculate it with the help of a formula, guys. And what is that? Adjoint of A divided by determinant of A. Okay, this is the formula that generally we use in order to determine the inverse. But here for PGCET examination, no need to get into the calculation part. I have already dealt with the adjoint part in our previous class, of course, on our academy app, guys. So here you only need to remember this statement, because on the basis of properties of matrices and properties of determinant, you will have to answer one mark question which will be asked in your examination. Okay, so please remember this statement. In case of a symmetric matrix, if you consider the inverse, even the inverse too will be symmetric, guys. Okay, symmetric matrix inverse ನೀವು ಕಂಡುಹಿಡಿದರೆ ಆ ಇನ್ವರ್ಸ್ ಕೂಡ ಸಿಮೆಟ್ರಿಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿನೇ ಇರುವುದು. This is an important statement. So if you want, you can check it out. Okay, you can take in any kind of a matrix, you can determine the adjoint, you can determine the determinant value, and then you can find in the inverse, which I think, guys, is not necessary because statement is already present. Okay, no need to go out for all the proof details. It will only consume your time and it will not be asked in your examination. Okay. So fine, guys, ಸಿಮೆಟ್ರಿಕ್ ಮೆಟ್ರಿಕ್ಸು ಅಂದರೆ ಇಷ್ಟೇ ರೀ. ನಮ್ಮ ಪ್ರಿನ್ಸಿಪಲ್ ಡೈಗನಲ್ ಎಲಿಮೆಂಟ್ಸು ಎದುರುಗಡೆ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸು ಸೇಮ್ ಆ್ಯಂಡ್ ಈಕ್ವಲ್ ಆಗಿ ಇರ್ತವೆ. ಸಚ್ ಆ್ಯಂಡ್ ಮೆಟ್ರಿಕ್ಸ್ ಈಸ್ ನೋನ್ ಆಸ್ ಸಿಮೆಟ್ರಿಕ್ ಮೆಟ್ರಿಕ್ಸ್. Now let us come back to skew symmetric matrix. Okay, before that, properties, guys. Properties, yes, properties of symmetric matrix are important. So as you can see here, for integer n, if A is symmetric, A raised to n is symmetric. It means that suppose you consider a matrix A. Okay, it is a symmetric matrix. ಒಂದು matrix A ಅಂತ ಹೇಳಿ ನೀವು ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ, ಅದು ಸಿಮೆಟ್ರಿಕ್ ಆಗಿ ಇದೆ. Even if you raise it to the n form, it means even if you keep on multiplying it, ಇದಕ್ಕೆ ನೀವು ಎಷ್ಟೇ ಆಪರೇಷನ್ಸ್ ಅನ್ನು ನೀವು ಮಾಡ್ತಾ ಹೋದರೆ ಮಲ್ಟಿಪ್ಲಿಕೇಟಿವ್ ಬೇಸಿಸಲ್ಲಿ ನಿಮಗೆ ಫೈನಲ್ ಆನ್ಸರ್ ಬರುವುದು ಸಿಮೆಟ್ರಿಕ್ ಆಗಿನೇ ಬರುವುದು ಅಂತ ಹೇಳುತ್ತೆ ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ. The first property suggests if A is a symmetric matrix, if you carry out any number of operations, finally you are going to get the answer in the symmetric form. Okay, that is the first property. And no need to go with the checking part here, guys. Idu ಮತ್ತೆ ನಾವು ಅಸ್ಯೂಮ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡೋದು ನೆಸೆಸರಿ ಇಲ್ಲ ರೀ. They are already true, so just remember these statements. Okay, the eigenvalues of a symmetric matrix are always real and positive. So eigenvalue ಅಂತ ಹೇಳಿ ಇಲ್ಲಿ ಒಂದು ಪ್ರಾಪರ್ಟಿ ಬಂದಿದೆ. So we'll just look into a short format, guys, what eigenvalues are. Okay, eigenvalues, guys, is generally a value. ಒಂದು ವ್ಯಾಲ್ಯೂ ಇದೆ ರೀ, ಅದು ಏನದು ಅಂದರೆ ಇಟ್ ಈಸ್ ಡಿಟರ್ಮಿನ್ಡ್ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ರ್ಯಾಂಕ್ ಆಫ್ ಅ ಮೆಟ್ರಿಕ್ಸ್. ಓಕೆ, it is determined on the basis of rank of a matrix. So eigenvalue is calculated. ಒಂದು equation ಇದೆ ರೀ, ಆ equation ಅನ್ನು ನೀವು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. There is an equation known as characteristic equation, guys. You have to substitute and solve according to that equation, and the constant that you are going to get in the end is known as eigenvalue of a matrix. So let me just consider an example here. Let me show it to you with the help of an example. So eigenvalues are not important. Examination alli adu kelalla ri, just to one mark statement basis mele keltare equation format alli. So what is that equation? We are going to see it here now. Okay, see here, guys. Suppose we have a matrix A. Okay, this A here represents the matrix, and lambda here, lambda is known as the eigenvalue. Okay, lambda, what is this lambda? Lambda is known as the eigenvalue, and I here represents the identity matrix. So this statement, A minus of lambda into I, the determinant of it should be 0. Initially, if a matrix A is given to you, you should take that to be in this format. Let me just consider a question here and I'll explain it to you. Okay, suppose this is the matrix that I'm considering. Okay, A is equals to 5, 4, 1 and 2. So now they'll ask you eigenvalue of this matrix is what. Okay, so what you have to do initially, you have to solve it out according to this equation here. Lambda, it is unknown guys, that is what we have to determine. I, we already know that I is the identity matrix, and A is the matrix that has been mentioned here. Okay, let lambda is equals to unknown. See here, according to our statement, A minus of lambda into I, the determinant of it is 0. Determinant of A minus of lambda I is equal to 0. This is the condition guys that has been maintained in order to find the eigenvalue lambda. So here now let us just substitute accordingly. Initially we are going to solve it out with the help of matrix. See, matrix A is nothing but 5, 4, 1, 2 minus of lambda into I. I'm going to write it down directly. Lambda into 1. Identity matrix is 1 0 0 1. If you multiply that lambda, it is going to be lambda into 1 lambda, lambda into 0 0 0 and lambda. Okay, these are the values. Now finally I'm going to get it down as 5 minus of lambda, 5 minus of lambda, and then 4 minus of 0, that is 4, then 1 minus of 0, that is 1, 2 minus of lambda. This is the matrix that I'm finally going to get. Now according to the condition here, the determinant of this matrix should be 0, so I'm going to consider the determinant. Okay, so the determinant of 5 minus lambda, 4, 1, 2 minus lambda is equals to 0. So now you have to solve it out according to the determinant process. So how are we going to solve it? We are going to cross multiply these terms here. Okay, 5 minus of lambda into 2 minus of lambda minus of 4 into 1, that is 4, which is equals to 0. 5 into 2. Now you have to follow the distributive law and simplify it. So 10 minus of 5 lambda minus of 2 into lambda plus of lambda square minus of 4, which is equals to 0. Okay, so now lambda square minus of 7 lambda plus of 6 is equals to 0. Now we have obtained this in the form of a quadratic equation. Now you already know how to solve quadratic equation guys. We need the factors of 6, and on addition we should get it to be 7. So I'm going to write it down as minus 6 and minus 1. Okay, so minus 6 into minus 1, that will be plus 6, minus 6 minus 1, if you add them, that will be minus 7. So what are the roots guys that we are going to get here? The factors we have to just change in the signs here. So minus 6 becomes plus 6, minus 1 becomes plus 1. So we have two roots here. Okay, as you might have seen and we have already seen guys, quadratic equation always has two values which are also known as zeros. So the two values that we are getting here is 6 and 1. So this lambda value that we are going to get, this value itself is known as eigenvalue. Okay, these values are known as eigenvalues of a matrix. Okay, so the eigenvalue of the particular matrix that we had taken is 6 and 1. 6 and 1. Okay, so generally eigenvalues are useful in case of linear transformations guys, like solving equations or questions which are on a linear basis. So there you will find the application of eigenvalues. But here that is all you need to know. The condition, determinant of A minus of lambda into I is equals to 0. Okay, so it involves eigenvectors too, but that is not for your syllabus, so no need to go into too much detail here. Okay, just remember the identity A minus of lambda into I is equals to 0. Okay, so that is how we usually go with the eigenvalues. Now here if you come back to the properties that we were looking for, properties of a symmetric matrix guys, eigenvalues of a symmetric matrix are always real and positive. Suppose you have a symmetric matrix A And if you calculate the eigenvalues of this symmetric matrix, you're always going to get them to be real and positive. Okay, it means that the roots will be always in positive form. Negative form it will not accept. ಸಿಮೆಟ್ರಿಕ್ ಮೆಟ್ರಿಕ್ಸಿನ ನೀವು ಐಗನ್ ವ್ಯಾಲ್ಯೂಸು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದರೆ ಅದು ನೆಗೆಟಿವ್ ಅಲ್ಲಿ ನಿಮಗೆ ಬರಲ್ಲ ರೀ, ಯಾವತ್ತು ಪಾಸಿಟಿವ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ಅಂತ ಹೇಳಿ ಈ ಸೆಕೆಂಡ್ ಪ್ರಾಪರ್ಟಿ ನಮಗೆ ಹೇಳ್ತಿದೆ. ಓಕೆ, ಸೊ ರಿಮೆಂಬರ್ ದಟ್ ನೋ ನೀಡ್ ಟು go on solving once and then in order to check what the roots will be. So in examination they might ask you eigenvalues of symmetric matrix are real and positive, imaginary, real and distinct anta heli. So the answer will be real and positive, guys. Okay now, so in case of a determinant, if you consider this, that will be b square minus of 4ac should be greater than 0. Okay, determinant quadratic equation b square minus of 4ac, this is how you determine the roots, whether they are going to be equal, whether they are going to be imaginary, whether they are going to be real. So b square minus 4ac should be greater than 0, guys, if the roots have to be real and distinct or positive. Okay, so now coming back to the third property here, determinant of a matrix and its transpose are same of a symmetric matrix. Just this point I had mentioned here, guys. If you consider the determinant here, determinant of a matrix and its transpose are one and the same. Symmetric matrix, if you consider original matrix and its transpose, they are both identical, they are both the same. So adjoint of a symmetric matrix is also symmetric. Adjoint, if you consider the adjoint here, according to this formula, if you determine the adjoint of a, how do we determine that? We usually change in the signs, guys, alternatively positive and negative, and then we consider the minor factors. Okay, minor factors, plus minus plus minus plus minus plus minus plus, this is how we go with the sign rule. And then we consider the minors here, minors of 1 1, that is we eliminate the first row, we eliminate the first column, we consider the determinant of the remaining terms. Okay, that is what we have seen, guys, in the previous class. Of course they will not be asked in your examination, but you should know them. So adjoint of a matrix, symmetric matrix, is also symmetric, that is the fourth point. And the last, inverse of a symmetric matrix is also symmetric. Mostly this last point is asked in PGCET examination for a number of times, guys. You have to remember all these points because they might be asked now and then. Okay, so that is all you need to know about the symmetric matrix. Okay, I hope it is clear, guys. So those guys who are watching me on YouTube, I hope you are understanding. So if you have any comments, guys, do let us know in the comment section. So Riorians who are watching me on app 2, I hope it is clear, guys. Viraj Javare, Anaga, fine. So now come back to skew symmetric matrix. Okay, we are going to look into the skew symmetric matrix. Now as the name suggests itself, guys, skew symmetric matrix is nothing but the change of signs. Forgive me, guys. So let me consider an example here. See, what is the practical application of matrices? We have already learned about matrices from our high school level, guys, of course in pre-university level, then in graduation too, and we are yet learning it in master's degree. What do you think is the importance of so what do you think is the importance of matrices? Okay, it must be some kind of importance, guys. So visible agi ಕಾಣ್ತಿದ್ದೀರಿ ಇದು? Okay, so Viraj avare clear, sir, fine, fine. So look here, guys, consider this example here. Okay, b is equals to 0 2 4 minus 2 0 3 minus 4 minus 3 and 0. So if you see here, I've taken this matrix as a skew symmetric matrix. See, First of all, this is a matrix. Okay, the principal diagonal elements are 0 here, and here the overlapping elements, they are equal but opposite in the sign value. Here it is 2 and here it is minus 2, here it is 4 and here it is minus 4, here it is 3 and here it is minus 3. So just like a symmetric matrix, the elements 2 will be overlapping on each other but in opposite direction. It means the signs will be opposite. In case of a symmetric matrix, this would have been positive 2 if this is 2, and this element will also be 2 in case of symmetric matrix. Okay, 0 2 4, then it should be 2 2 and 2, that would be symmetric. And this is 4, this should also be 4 in case of symmetric. And if this is 3, this should also be 3 in case of a symmetric matrix. The only change here in case of a skew symmetric matrix, guys, is the sign values. The overlapping elements will be equal but the signs will be in opposite direction. Okay, the signs will be opposite. If this is 2, this will be minus 2. If this is 4, this element will be minus 4. If this is 3, this will be minus 3. Okay, so these kind of matrices or matrix is known as a skew symmetric matrix. Okay, skew, as the name itself suggests, skew means a little bit of a change, guys. So skew symmetric matrix. Okay, so I hope it is clear, guys, about the skew symmetric matrix. Now here at the bottom, if you see, I have considered the transpose of a skew symmetric matrix. Okay, this is our matrix here, skew symmetric matrix. We are going to convert the rows into columns in case of transpose. So 0 2 4, that row will turn out to be 0 2 4, the first column, and minus 2 0 3, the second row here will become the second column. The third row here has become the third column. So if you can see here, don't you think the matrix B is a negative of the transpose of B? Okay, suppose if this is your matrix B, this, don't you think we can write it in this fashion, negative of the transpose itself? Okay, a negative of transpose. B matrix is equal to negative of transpose of the matrix B, and this condition holds true only for skew symmetric matrix. Okay, this condition holds true, guys, for a skew symmetric matrix. Okay, so that is what you needed to know about the skew symmetric matrix. Okay, whenever a matrix B has been given to you, whenever a matrix B or any other matrix A has been given to you, in case of a skew symmetric matrix, this matrix B will be equal to its transpose but in the negative form. Okay, the transpose of a matrix will be equal to the original matrix but in the negative form, or you can also write it in this fashion, B transpose equal to negative of B. Okay, so both these conditions hold true for the case of skew symmetric matrix. Okay, so that is all that you need to know about skew symmetric matrix, guys. No need to go into too much detail here. Okay, so I hope it is clear. Okay, now so matrices, guys, yes, matrices, as I was telling, see, matrices have been included in master's degree and in all the other fields because they are really very important in order to solve, as I told you, linear format of questions. Okay, linear format of questions. Whenever in case of physics you might take in field of research, the application of matrices is highly useful. So even though it is not that difficult, one should be able to know how to sustain with matrices whenever the questions approach. Okay, so I hope that is clear, guys, with respect to matrices. So now let us come back to, you know, the rank of a matrix. Okay, see, guys, determinants and matrices are very closely related to each other. You know, if you consider matrices, they are not that different from determinant because each and every determinant is a form of a matrix. Determinant is a form of a matrix, especially a square matrix. Okay, each and every determinant is a square matrix. matrices and determinants are interrelated. They are both connected to each other. There was one student who had asked me a question. He had asked me that 2, 3, 1, 4, 5. So how do you consider, suppose this is a matrix A. So how do you determine the determinant of this? Okay, this is a rectangular matrix, and he had asked me, sir, idu ಒಂದು rectangular matrix agi ide, how do you find the determinant of this? So see guys, in order to find out the determinant, if you want to find, the matrix should be in square format itself. Okay, the order of the matrix should be 2 cross 2, or it should be 3 cross 3. Okay, or it can be 4 cross 4, 5 cross 5 guys. Of course it is a square matrix, those are, but here we generally go out with 2 cross 2 and 3 cross 3. So determinant can only be calculated for square matrix. Each and every square matrix has its own determinant. What is the value of that square matrix? That is what we usually calculate in case of determinant. Okay, so now we are going to consider what is the rank of a matrix and how do we determine the rank of a matrix. Okay, just a small example guys. Once again, method in order to identify the rank is not in us, just to let you know. So what is the rank? What is the rank of a matrix? The rank of a matrix is nothing but the number of non-zero rows or columns. Okay, non-zero rows or columns in a matrix. Suppose you have a matrix that has been given to you. If you solve that matrix, the matrix reduces for some or the other reasons, the number of non-zero rows, that is what the rank of a matrix is. For example, let me consider a matrix 0, 0, 2 and 3. Okay, this is a matrix that I am considering. So what is the rank of a matrix here? Rank of a matrix is 1 guys. Why? Because there is one row which is non-zero. Fine, here the first row is 0, 0 and 0. What does the matrix say? The rank of a matrix, the number of non-zero rows or columns. So the non-zero rows here is only 1, so that is why the rank, that is written as row of A. If you consider this matrix as A, row of A, that is rank of A is nothing but 1. Okay, if I consider another matrix B and I take that to be 0, 0, 1 comma 2, so what is the rank of a matrix? What is rank? Number of non-zero rows or columns. So the first column here, that is 0. So how much is the second column here? 1 and 2. So it is non-zero. What is the rank? Rank once again guys of a matrix B will be 1. Okay, so as you might have already guessed it guys, if the determinant of a matrix is 0, then such a matrix is known as a singular matrix. Okay, we have already seen this guys in the last class. Of course I didn't solve the questions here because no need to solve. This is just a condition. Determinant of A, if it is 0, then such a matrix is known as singular matrix. And if the determinant of A is not equals to 0, then such a matrix, as you might have guessed, is a non-singular matrix. Okay, non-singular matrix. So these are the two conditions which are important. And then A and A inverse. Okay, suppose there is a matrix A, and if you consider the inverse of that matrix, how do you determine the inverse of a matrix guys? Inverse of a matrix is usually calculated as adjoint of A divided by determinant of A. Of course there are many methods too in order to find out the inverse, but we are going with the formula here. So A inverse is equals to adjoint of A divided by the determinant. Once you calculate the A inverse, and if finally you multiply that inverse with the original matrix, matrix A and its inverse, if you multiply, that condition will hold true, A inverse A. Okay, this law here follows commutative property. A and A inverse, inverse and the original form of a matrix, they are commutative. Here the case commutative. Why commutative? Why not any other matrix? Why only original matrix and its inverse, because if you consider the product of a matrix A and its inverse, you are going to get identity matrix. Okay, finally when you solve these both matrices, you are going to get identity matrix. If it is 2 cross 2, 1 0 0 1. If it is 3 cross 3, 1 0 0 0 1 0 0 0 1. Okay, so this law holds true only for A and A inverse. Okay, this law doesn't really hold true for other form of matrices. Just like A is a matrix and B is another matrix, we cannot say A into B is equal to B into A. Okay, A into B is not equal to B into A, but here in case of inverse of itself, it holds true. Why? Because that will give us identity matrix. Okay, so please remember these three conditions, guys. This and of course this too, because commutative property doesn't hold true for matrices. Okay, please remember these four properties which are also important. Okay, now so now guys, I hope you are able to understand, those guys who are watching me on YouTube. So Viraj, what if it have single zero in a row? Single zero in a row. I think you are speaking about rank. Yes. So in a rank of a matrix, sir, either the complete row should be 0 or the complete column should be 0. Suppose here it is 0 and 1. Then this cannot be known as a non-zero row. All the elements should be 0. Completely the row should be 0 or completely the column should be 0. If it is only 1 0, then we will not consider such a row or such a column to be non-zero. I hope it is clear. Okay, so that is all about matrices, guys. Now rank of a matrix I was talking about. I hope you are able to understand, guys. Those guys who are watching me on YouTube, if you do understand, please say something in the comment section. It feels like I'm speaking. Of course, Riorians are watching me. Anaga is present. Viraj is present. Chetan is also here. Rahul is here. They all do respond here, guys. But on YouTube, I don't understand whether you are understanding or not. So please let me know in the comment section. Okay. I hope you guys all no offense with me talking in that manner. So now let us consider an important question here, because this kind of question might be asked in your examination. Okay, this question is important because it is based on the statement here which I just looked into. Determinant of A is equals to 0. That is the condition we are going to use up. Okay, so this is the question, guys. Hope it is visible. Okay, so see, if a matrix A is a singular matrix, then find the value of x. Okay, this kind of question might be asked in your examination because it is based on a statement here. So how do we solve it, guys? In this question, he's clearly mentioned it here that A is a singular matrix. Okay, A is a singular matrix. So what is the condition for singular matrix? What kind of a matrix can be called as a singular? If the determinant of a matrix is 0, only and only then it is singular. Correct? So we are going to use this condition in order to find the value of x. Okay, so determinant, how do you solve it out? I hope you already know that, guys. See, 1, this first position, 1 into, we eliminate the first row, this first column, and we take in the determinant of the remaining elements here. Okay, so 1 that we have written it here. So 2 into minus 3, that is minus 6. Okay, then minus of 2 into 1, that is 2. Okay, then this here signs will be in alternate fashion. Whenever you consider the determinant procedure, signs will be in alternate fashion. This is plus 1 we have taken, then it will be minus of the second term here. Okay, minus of minus 2, minus of minus 2. Now we eliminate respectively first row, the second column, and the remaining elements 1 1 x and minus 3. We consider the determinant here. So minus 3 into 1, that will be minus 3, guys, and then x into 1, that will be minus of x. Okay, because we usually consider the difference. This minus here represents the difference. Okay, so next it is 3, so plus 3 into, we eliminate the first row, we eliminate the third column, then determinant of these minor values here remaining, 2 into 1, that is 2, minus of 2 into x, that is 2x, and this entire condition is equal to 0. Why? Because it is a singular matrix. Okay, so now we need to solve it out. Minus 6 minus 2 will give us minus 8, so minus 3 minus 6, and this will be positive here, minus and minus plus 2 into minus 3, okay, that will give us minus 6, and then minus minus plus 2 into minus x, that will give us minus 2x. Okay, then plus of 3 into 2, that will give us 6, plus into minus, that is minus 3 into 2, that will once again give us minus of 6x. Okay, so now here plus 6 minus 6, they both get cancelled out, so now it remains minus 8 minus of x, sorry, minus 6x minus 2x, that will be minus 8x, which is equals to 0. So 8x is equals to minus of 8. So what is the value of x? Minus of 8 divided by 8, which is equal to minus of 1. Okay, so the value of x that we needed here, guys, is minus of 1. So how did we solve it? He has clearly mentioned it in the question that the given matrix A is a singular matrix. Okay, whenever the matrix is singular, we have to take in the determinant as 0 and then go on with the calculations. So as we just did, I hope it is clear, guys. Okay, so now let us consider, I hope you understand how we go on with the determinants, guys. Determinant solve ಮಾಡುವುದು ಹೇಗೆ ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಗುರುತಿದೆ. I believe that, I know that, because it is very easy, guys. So I'm not spending too much of time here, so no need to go out with those, because those kind of questions will not be asked. Only property based questions will be asked in your PGCET examination. Okay, so now let us consider how to deal with the rank of a matrix. Okay, so now let us consider another question, and this will be the last question, guys. So find the rank of a matrix. So those guys who are watching me on YouTube, guys, like this video, share it, please comment if you have any comments that we want to know or we should know. So find the rank of a matrix. He's asking us to determine the rank. So how to determine the rank, guys? Now there are number of methods that we can go on in order to determine the rank of a matrix. The first method is known as a normal method. Okay, there is a normal method, then there is a row echelon method, and then there is the method of elimination. Okay, there are a number of ways, but we'll just look into a simple manner. We'll just look into a minor method. Okay, elimination method, which it is also known as. So initially what we are going to do in order to determine the rank, here there are no non-zero rows or columns here. Okay, each and every element is completely occupied, but if this matrix undergoes transformation, we consider the reduced value. Okay, we consider the reduced value. 3 into 3 matrix, that is the order of the matrix here, that is, it is not the completely reduced value of a matrix. We have to reduce it out in order to determine the rank of a matrix. And how do you determine the rank? Initially we go on with the determinant value. Okay, the first value, the first thing that we do is to look into the determinant. So determinant of A, 1, we are going to determine the value here again. So 1, eliminate first row first column, 9 into 5, that will be 45, minus of 8 into 6, that will be 48. Okay, so plus, then it will be minus sign, then the second term here, first row second column will eliminate, and then it is 2 multiplied with 9 into 4, that is 36, minus of 7 into 6, that is 42. And now it is the last term of the row here. So plus of 3. Initially it was plus, then it is minus, then it is plus. So plus of 3 into, eliminate the first row, the last column, 8 into 4, that is 32, minus of 7 into 5, that is 35. Okay, so now you need to solve it out. 45 minus 48 is minus 3. So 36 minus of 42. This will be minus 6, guys. Correct? 36 minus of 42. Minus 6 into minus 2. That will be plus 12. 32 minus 35. That will be minus 3. Minus plus is minus, and that will be 9. So minus 9 minus 3 plus 12. That will be 0. Okay. So the determinant value that we have gotten here is a 0. And now what we do here, the rank of a matrix cannot be determined if the value is 0. Okay, initially when a matrix is given, we have to find out the determinant here. If the determinant is equal to 0, then we cannot say the rank of a matrix. It will not be determined, guys. It will not be determined. And always remember, rank of a matrix will always be less than the order of the matrix. Okay, it cannot be more than the capacity itself. The order here is 3 cross 3. Number of non-zero rows cannot be more than 3 rows when you have 3 rows itself. ಅರ್ಥ ಆಗ್ತಿದೆ. ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿ ನಿಮಗೆ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ 3 ರೋಸ್ ಇದ್ದರೆ ಆ 3 ರೋಸ್ಗಿಂತ ಜಾಸ್ತಿ ಝೀರೋಸ್ ನಿಮಗೆ ಇರಲಿಕ್ಕೆ ಸಾಧ್ಯತೆ ಇಲ್ಲ. ಸೊ ದ ರ್ಯಾಂಕ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ ಲೆಸ್ ದ್ಯಾನ್ ದಿ order of the matrix. Okay, it can be equal, guys. It can be equal to the order of the matrix, but it will never be greater than 0. Sorry, it will never be greater than the order of the matrix. Okay, now here, if the determinant is 0, what we have to do, we have to consider in the minor, guys. We will have to take in either of the minor values here. So what I am going to do, I am going to take in these values here. Okay, 1, 2, 4 and 5. Fine. Here the last term 9, I'm eliminating this row and I'm eliminating this column. So the remaining terms 1, 2, 4 and 5. So this will be the minor here. You can take in minor of any term. You can take in the minor of any term. So initially 1, 2, 4, 5, that will be available at the go itself. So I'm taking that. Okay. So determinant of 1, 2, 4 and 5. So 5 minus of 8, what is that? That is minus 3. Okay, the value here that we have got is minus 3, and this determinant is not equal to 0. We have got the value as minus 3 here. Okay, so the determinant of A, or let us take this to be B, or we can take it to be minor, so it is indefinite. I'm just saying it out loud here. Let us take this one to be the minor. Okay, this is the minor here. Minor of A, that is third row and first column, sorry, third row, third column, A33. Okay, so here whenever the determinant of any matrix is not equal to 0, then the rank of a matrix will be equal to its order. Okay, ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಅರ್ಥ ಆಗ್ತಿದೆ ರೀ ಹೇಳ್ತಾ ಇರೋದು ನಾನು. ಓಕೆನಾ, ನೋಡಿ ಮೊದಲು ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅನ್ನು ನಮಗೆ ಅವರು ಕೊಟ್ಟಿರ್ತಾರೆ. ಓಕೆ, ಸಿ ಇನಿಷಿಯಲಿ he will have given us a matrix. We have to find the value of that matrix. If the value is 0, then we cannot determine the rank. We have to get the value of a determinant to be non-zero. Okay, we have to get it to be non-zero. So what we have to do next here, we have taken in the minor 1, 2, 4 and 5, minor of 9 here, 3, 3. Okay, so 1, 2, 4, 5. Now the determinant we are getting it to be negative. So either the determinant should be negative or it should be positive. So once we get that value, then we can say the rank will be equal to order of the matrix. So what is the order of this matrix here? The minor matrix that we have taken, 2 cross 2. Okay, 2 cross 2 is the order of the minor matrix here that we have taken. So we can say the rank of a matrix is equal to 2. Rank of a matrix is equal to 2. Now here suppose the value would have been something. Okay, the value here would have been any number apart from 0. Let us take it to be 4. Okay, the value, if the determinant value here would be or would have been 4, then we could have said the rank of a matrix is equal to the order. What is that? 3. Okay, the rank of a matrix would have been equal to the order. ನಮಗೆ ಡಿಟರ್ಮಿನೆಂಟ್ ವ್ಯಾಲ್ಯೂ 0 ಬರಬಾರದು. 0 ಬಂದರೆ ಮತ್ತೆ ನಾವು ಮೈನರ್ ಅನ್ನ ತಗೊಳ್ಬೇಕು ಮುಂದಗಡೆ. ಓಕೆನಾ? ಸೊ 0 ಬಂದರೆ ನಮಗೆ ರ್ಯಾಂಕ್ ಹೇಳಲಿಕ್ಕೆ ಬರಲ್ಲ ರೀ, ನಾನ್ ಝೀರೋ ವ್ಯಾಲ್ಯೂ ಇರಬೇಕದು. ನಾನ್ ಝೀರೋ ವ್ಯಾಲ್ಯೂ ಬಂದುಬಿಟ್ಟರೆ ಆ ಡಿಟರ್ಮಿನೆಂಟಿನ ಆರ್ಡರ್ ಎಷ್ಟಿರುತ್ತಲ್ಲ ಆ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸು ಅದೇ ನಮ್ಮ ರ್ಯಾಂಕ್ ಅಂತ ಹೇಳಿ ತಗೊಳ್ತೇವೆ ನಾವು. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಆಲ್ ದ್ಯಾಟ್ ಯು ನೀಡ್ to know about the rank of a matrix, guys. So once again, this is not important with respect to your examination ಅಲ್ಲಿ rank of a matrix ಅನ್ನ find out ಮಾಡಿ. Please find out the rank of a matrix. They will not ask you directly according to the method, but they will ask you the conditions. Okay, they'll ask you the conditions. The rank of a matrix, can it be equal to order of a matrix? Can it be greater than order of a matrix? Can it be less than order of a matrix? Okay, this is the condition. So please remember, rank of a matrix can be equal to, okay, can be equal to order of a matrix, or it can be less than the order of a matrix. Okay, it will never be greater than it cannot exist, because if there are 3 rows and if you say that there are 4 zero rows, then it is not existable. Okay guys, so rank of a matrix is always less than the order of a matrix or is equal to the order. Okay, so this is another condition. Please remember that condition too. Okay, so that is all guys about matrices. So about determinants, the other thing that you need to know is the properties, guys. Okay, properties of determinants. There are 6-7 properties of determinants. Like if you change in the rows, if you change in the columns, if you change in the signs, what will happen? That is the only thing that you need to know, guys. That of course I will consider in the next class. Okay, there are 6 properties, I guess 6 or 8 properties, guys. We'll look into those properties in the next class. So those guys who are watching me on YouTube, guys, if you like this video, hit the like button, share it, subscribe it, and please let us know your comment section. And I hope Reorients who are watching me on app, Viraj, Anaga and Rahul, you are able to understand what I'm trying to speak out. Okay, so for those guys who are watching me on YouTube, guys, so YouTube, like this video, guys, share it, subscribe it. We'll meet once again in a new session. So join in soon, guys. Rio Academy is going to launch up a new batch now, the 3rd batch. Examinations are near, so contact us at the contact number and do join us. Okay, join Rio Academy and be a step ahead of yourself. That is all for today, guys. Thank you once again for watching us live. We'll be back again with a new session. Up till then, have a great time, take care, and bye, guys.